So today we're going to do section 4.9 and we're going to perform congruence transformations. We've kind of already started transformations in the last chapter, or actually just on the last test in the beginning of this chapter, and now we're going to do it more with coordinate notation. So we're going to kind of throw algebra in there just a little bit. Alright, so think back to the beginning of the chapter, okay? When we did transformations, we said rigid motions were types of transformations that preserve the same shape and size. Okay, so that's just going to be another word for congruence transformations. And if you think back, the three types of transformations that we had were translations, which remember were like glides, okay? We just kind of slide the figure to the left, to the right, up or down, or diagonally. Then we had reflections, when we just flipped our shape over. And then our last one were rotations, where we kind of took an angle and we had a center and we just kind of moved it around the circle a little bit. We're mainly going to focus on translations and reflections today though. Alright, so here are three examples of our transformations. I want you to go ahead and see if you can name them off real fast. So copy these down and try and answer them, and then we'll go over it in just a second. So whenever you're ready, hit your space bar. Alright, so hopefully you can remember these from the beginning of this chapter. So A should have been a rotation because we have a center point P that we can rotate this object kind of around a circle a little bit. B is going to be a reflection across our line H. And then C is a translation where we move that object down. Alright, now here I've shaded all the ones that are pre-image. A pre-image in a transformation is going to be the original figure. It's going to be the image of the figure that starts us off. The image of a transformation is going to be the picture that we end up with. So it's going to be all the figures shaded in purple. Okay, now that's just something we just kind of have to remember. So pre-image, remember before, and then image is going to be after a transformation. So pre-image before the transformation, and image is after the transformation. Alright, so this is going to be kind of how this section is going to be different than our section before. So we're going to look at our coordinate notation for translations. So remember, a translation is going to be a slide. Okay, we're not going to flip our shape around or anything like that. We're just going to move it. Okay, so think about a coordinate plane. We always have coordinates, our x and y coordinate. Okay, so over here on the left is going to be our pre-image. This is going to be the coordinate that we start out with. And then over here on the right is going to be our image. It's going to be after a transformation. Okay, now you can kind of think of this as our actual transformation. So a translation is always going to take an x coordinate and you're going to add or subtract a number. And it's going to take your y coordinate and you're going to add or subtract a number. Here, when we say A is going to be whatever number we're adding or subtracting to x. And if A is positive, okay, so if we add a number, I'm going to move, my figure is going to move to the right that many units, whatever A is. Okay, and if A is negative, so if I subtract a number, then I'm going to move my figure to the left that many units. Alright, so we also have a vertical shift. Our vertical shifts are going to be represented here by our B, but our vertical shifts are just going to be whatever we add or subtract to our y coordinate. Alright, and this is going to move it up or down. So if we add a number to y, okay, say we have y plus 6, then we're going to move our figure up 6 units. And if we subtract a number, say y minus 2, then we're going to move our figure down 2 spaces. Okay, so positives are up or to the right, and our negatives are down and to the left. Alright, so this is our first example. This is going to be an example of how to use the coordinate notation for a translation. So here, if you notice, our translation is going to be xy is going to be transformed to x minus 4 and y plus 1. So one way that we can do this is either you can think about, since we're subtracting 4 from our x, we're going to move to the left 4. And since we're adding 1 to the y, we're going to move up 1. Alright, but if in doubt, you can always write it out. So what I suggest you do is you should always look at all your coordinates of what you are starting with. So here we can see that A is at 1, 1, B is at 6, 5, and C is at 6, 1. So go ahead and write that down. Alright, so now that we've written down our coordinates, what I want you to do is write x, y above your coordinates, put an arrow, and then put your transformation next to it like I've done. Alright, all I'm going to do is all my coordinates underneath my x are going to be my x and my transformation. So here when I have my point A, I know x is 1 and y is 1, so I plug it into my transformation. So x minus 4 becomes 1 minus 4, and y plus 1 becomes 1 plus 1, because here x is 1 and y is 1. Alright, then I just simplify, so 1 minus 4 becomes a negative 3, and 1 plus 1 is 2. So I know my new coordinate for A is negative 3, 2. Then I'm going to do the same thing for B. So B, I have x is 6, so I plug it in and get 6 minus 4. And then I know y is 5, so I plug it in and I get 5 plus 1, so it simplifies to 2, 6. So I know my new B is going to be at the point 2, 6. When I plug in my point C, I get 6 minus 4, which is 2, and 1 plus 1, which is 2. So I know C is at 2. Alright, so see if you can process that information, see if you can do it for yourself. Whenever you're ready, press the space. Alright, so now all I've done is I've gone and I've plotted my new points and I've connected the dots. So if you notice, if I go from my original A, this black A, and I move it over here to this pink A, I can see that I'm moving to the left 1, 2, 3, 4 spaces, and I'm moving up 1. Alright, now we kind of discussed that earlier, but when I'm subtracting 4 from my x, I move to the left 4. When I add 1 to my y, I move up 1. So you can see my entire figure has just been shifted up and to the left. Alright, that's just a plain transformation. What we're going to do next is reflections. So what I want you to do for the next examples are kind of pause the video and see if you can do them for yourselves. Alright, so now we're going to look at reflections, our coordinate notation for reflections. So we have two different kinds. We're first going to flip our figures over our x-axis. So remember, that's our horizontal axis. So we're just going to kind of flip it up or down. Okay, so when we reflect our figures across the x-axis, all we're going to do to our coordinates is multiply our y coordinate by negative 1. So our coordinate xy becomes our coordinate x negative y. Again, xy is going to be your image, or I'm sorry, xy is your pre-image. That's what we're starting off with. And your new coordinate x negative y is going to be our image. So that's going to be after our transformation. Alright, so here's our second example. This is going to be an x-axis reflection. So what I have for you here is a figure in blue. This is going to be our pre-image, and I have your pre-image coordinates over here on the left. Okay, so what I want you to do is copy this down, okay, and then I want you to put above it, like we did before, put x, y, and then arrow, and whatever our coordinate notation for our x-axis reflection is. So what I want you to do is put that down on your sheet of paper, see if you can figure out my new coordinates. Alright, and whenever you have that done, press your space bar, see if you got it right. Alright, so hopefully you got this down, but our x-axis reflection, remember, is going to be that xy. It's going to be transformed into x negative y. So all I'm going to do is take my y coordinate of all of these coordinate points, and I'm going to multiply them by negative 1. So A starts off at 1, negative 1, so I multiply my y, which is negative 1, by negative 1, so I'm left with my new A at the point 1, 1. B is at the point 5, negative 1, so when I multiply my y coordinate by negative 1, I get 5, comma, positive 1, so that's my new B. Alright, C is at the point 7, negative 4, so when I multiply my y coordinate by negative 1, we get that our new C is at C is at 7, 4. And then D goes from 1, negative 4 to 1, positive 4. Alright, so then all I'm going to do is I'm going to connect the dots, and I can see that my blue shape is going to be transformed onto that dark maroon shape, okay? And what you can kind of think about is if I fold this screen in half over my x-axis, these shapes would be exactly on top of each other. So I preserved my shape, I preserved my size, all I've done is I flipped that shape over my x-axis. Alright, so our last coordinate notation that we're going to do for today is going to be a reflection across our y-axis. So our y-axis is our vertical axis. So all we're going to do is we're going to take our shape and we're going to flip it across vertically. Okay, so what we're going to do is we're going to multiply our original image, our xy, okay, and we're going to get negative xy. So we're going to multiply x by negative 1. Okay, so again, xy, the coordinate that we're going to start off with is our pre-image. Okay, so the image before our transformation. When we multiply x by negative 1, we're going to get our image. So that's going to be our new coordinate of our new shape. Alright, so whenever you got this down, press the space bar and we'll try our new example. Alright, so we kind of got the basic picture. So here we have our blue image, A, B, C, D, and I already wrote down the points for you. What I want you to do is I want you to flip this shape into a y-axis reflection. So I want you to do the same thing we did before. Go ahead and write down the transformation above these coordinates, and then apply your transformation to your coordinates and see if you get the same new coordinates as I do. Alright, so whenever you finish that, press spacebar and see if you got it right. Alright, so when we have a y-axis reflection, we're going to multiply all of our x coordinates by negative 1. So A is going to start out at negative 4, 2, and we're going to end up at 4, 2. B is going to be transformed from negative 7, negative 1 to a positive 7, negative 1. C is going to go from negative 7, negative 6 to a positive 7, negative 6. And D is going to go from negative 3, negative 2 to a positive 3, negative 2. So all I'm going to do is I'm going to take all my x coordinates and make them positive since they're all negative right now. Alright, so we just do the opposite sign, and then when we go and connect the dots, we can see that my new shape, my red shape, is going to be exactly the same distance from my y-axis. All we're going to do is we're flipping it across it. So I could fold the screen in half vertically and see that the shapes would be exactly the same right on top of each other. Alright, so if you have any questions, raise your hand and let me know now. If not, go ahead and start on the problems assigned to you.